Hi everyone, this is Madhura here, and I'm going to talk about detection of anomalous checklists in eBird data using machine learning. Just to give a background, I'm a technology professional with a keen interest in the area of citizen science and conservation. I started exploring opportunities of utilizing machine learning with the citizen science databases such as eBird. Given all these databases are crowdsourced, and considering the quantity of data, it was learned that data quality is an area which needed attention. In these databases, such as eBird, there has already been established processes for quality monitoring with the combination of filter and manual reviews. Now let us see how machine learning comes into picture in these kind of use cases. Firstly, eBird dataset is large and well-defined, which fit easily into the purview of machine learning applications. The current system of filters which flags the anomalous observations, it works with predefined threshold values on the list of different aspects related to the observation itself. So when we consider machine learning, which works by detecting the patterns from data with algorithms and statistical techniques to draw inferences. In this case, to detect anomalies. And with this approach, more dimensions of data that could be considered. So anomalies at the checklist level could also be a possibility that we learned. Also, considering the algorithms which learns from the data, so the possibility of bias that gets introduced by static filter themselves is far less. So the approach, when we talk about the approach that was considered to bring the models into the ML into the system is to introduce them as an augmented application into along with the filters and reviews. So the data is data from the eBird database is provided as an input to train the model, which will further score the checklist and fix anomalies. And then these anomalies are reviewed by the reviewer to take appropriate action. So let us discuss the model a little bit in more detail. At individual state level, different models are built. The starting one being Karnataka. To talk about the process of building the model, first data is cleaned. That is, for example, pick out only the approved checklist or drop the duplicate considering the group checklist and so on and so forth. Further features are extracted. When we say feature, it is different dimensions of the data. So different techniques such as geospatial analytics for extracting the location features, statistical model for extracting the observer skills, and so on. Once all the data is prepared, this is fed into training two different models. We're built to build two different models based on different modeling paradigms. One is decision tree, another is neural network, to score and pick anomalies from different perspectives. After the base model is built and validated and deployed, monthly predictions are done to pick anomalies for new checklists submitted or changed over past month duration, 1 month window. Also, the base model is again trained each month as of now till the model is model matures. Coming to the results and evaluation methods that has been used, the set of checklists with the combination of anomalous and non-anomalous checklists were provided to the reviewer community and requested them to grade the checklist between 1 to 5 scale, 1 being the best checklist, good checklist, non-anomalous checklist, so to say. Which was then compared against the anomaly score given by the models themselves. The current status of the evaluation of the model, based on the current status of the evaluation, the model is performing at around 80% accuracy, which could be further tuned for better performance. So this is just a tip of the iceberg. Lot could be done, starting from including more dimensions of data such as land cover, species specific statistics, and so on. Looking beyond the data quality, there are many possible use cases such as flagging anomalies, flagging anomalies in bird trends or migration patterns, and so on. So there could be many more. So far, this has been an exciting project. I would like to thank Karnataka reviewer community for extending their support and reviewing the checklist. Also, special thanks to Praveen Jayadevan from Bird Count India for guiding through the project. Thank you everyone for tuning in and listening to the presentation.